today's session. I would like to welcome you all to this session of Augmented Intelligence Workshop. As you know, in this series of short talks, we are exploring how to extend our minds through our social networks of other humans and our technical networks of various machines. The workshop is organized by Rob Goldston and Marina Dubova from Indiana University, Gautam Biswas from Vanderbilt University, and myself. So this meeting, as you've seen, is being recorded. It will be posted on the workshop YouTube channel, so please make sure your microphone is turned off at all times, except when you're speaking. And feel free to post any meeting-related thoughts and questions in the chat window. We will post the chat later on our Slack channel. You're also welcome to post directly to Slack and use it to chat with other participants, post relevant publications, and so on. After the talk, you can use raise your hand function or just yell, and I will moderate the discussion. Today we have two wonderful speakers, Danielle McNamara, who is the Director of the Science of Learning and Educational Technology, SOLET Laboratory at Arizona State University, and Niki Kittur, Professor of Human-Computer Interaction at the Institute of the School of Computer Science at Carnegie Mellon. So without further ado, Danielle, would you like to take it away?
All right, sure. All right, I assume you see my screen okay. Great, and you've got my sound. Lovely. All right, so the title of my talk's Leveraging Learning Engineering to Orchestrate and Enhance Learning. So where'd that come from? Well, let's start with the title of this workshop. So as I am a linguist at heart, I'll admit it, and so I took this title and started parsing it down. And when I hear augmenting individual intelligence, I think of learning. And then when I think of technologies, I think, and along with augmenting individual intelligence, I think of artificial intelligence. And so, and then I put that together with collaborating with people. And what I think about when I think about collaborating with people, you might think about education where we're collaborating or engaging, helping people to collaborate. But I thought of another thing, and that was learning engineering, which pretty well defines a lot of what I do. So that's what I decided to talk about today. So what is learning engineering? So we can define learning engineering in a lot of different ways. If this is new to you, basically it's a multidisciplinary, transdisciplinary application of evidence-based principles from, some people say, learning sciences, or more broadly, education and behavioral sciences. So cognitive learning, social developmental. It's really bringing theories together and combining that with computational and design methodology in the computer sciences and, of course, engineering, to create effective, engaging, and learning experiences, support the difficulties and challenges of learners as they learn, and in turn come to better understand learners and learnings. So, and if you'd like a really fantastic book on this, please consider reading Goodall and Kolodner's Learning Engineering Toolkit, which they've just put together with a group of learning engineers and people doing research in this. It's a real page turner, so I think you'll enjoy it. So what are the key ingredients to learning engineering? It's debatable, but a lot of people say that large-scale data is very critical to that. And I want to talk more about why. And then the other two ingredients is learning knowing what matters, analyzing the data to make predictions. So this is kind of where the analysis and intelligence coming in, creating algorithms so that we know what matters in learning environments. And then critical to this is then taking actions. So agile iterations and manipulations, so to speak, but in a more fast, rapid, iterative changes to improve learning environments so that we understand what's going on. So I see this in a landscape of learning sciences. So think about learning sciences or educational research. We can think about that in terms of contextual factors as well as student factors. So questions about what do they learn? How do they learn? And then who is the student? And of course, what we're usually trying to look at are the outcomes. So sometimes people are looking at short-term outcomes, behavioral outcomes, both in the short term and the long term. So retention over time, transfer of learning, and then as far out as career success. So if you think about that, we can think about if you do research and learning, if you happen to be a person who is thinking about these factors, maybe you'll find yourself in terms of looking at research to understand these factors. Who is the student? Or research to build. So you might be, or research to predict. So for example, you might be in the learning and cognitive sciences, or you might be building educational technologies, or even curriculum and instruction outside of technologies. And then on the other side, there are many people who are working to build algorithms to predict. So you might be trying to predict student factors. So for example, I do work that uses various features to predict students' prior knowledge and skills. Or you may be trying to predict working memory or various aspects of psychosocial factors. And in turn, you use those student models, some people use those student models to predict outcomes. So ultimately in learning research, we're attempting to build models that will predict the extent to which someone will learn the material or be engaged or retain the information over time, and then ultimately will they graduate from college. And in turn, we are using this information to build educational technologies sometimes, or build curriculum, build instruction. So looking at those contextual factors, we're sometimes building these environments to augment the learning experience, to augment intelligence, so to speak. So, for example, just to ground this a little bit, there's a lot of work in the MOOC work where people have used observables. So for example, participatory actions such as doing homework or watching videos, which is the degree to which somebody participates is very predictive of retention over time and whether someone will complete or not complete the work. Other people have focused on psychosocial factors like anxiety or self-regulation and sought to predict engagement and motivation. You might be looking at testing intervals. I think there's quite a few people looking at generative activities and then manipulating those activities to enhance both short-term and long-term success. But one of the things we know is there is no silver bullet. So we have, sometimes we have issues, for example, of the degree to which these studies replicate or the degree to which they scale. And what we know is that looking at these complex factors and complex environments requires looking at multiple factors across multiple contexts. And moreover, getting away from a single theory, looking at things with multiple theoretical lenses, looking at things from multiple vantage points. And one of the things I wanted to point out is, you know, if you think about learning engineering, we don't have to have large data to do some of the studies, but what we do need, we need large data in order to be able to look at these multiple factors at the same time. So moving away from just looking at, for example, anxiety and its effect on learning, or working memory and whether or not somebody pays attention to something, but putting these factors together in very complex models means that we need to think about large scale data and creating the means for people to do studies at large scales. And another thing this means is that it means that we need multidisciplinary collaborative teams to do that. So there's not one person who can look at all of these factors and create these complex environments and do so in an agile way. It's a very collaborative process. And that's the value of learning engineering, people working together to solve these complex problems in complex environments. So this brings me to the title of my talk, which I call Leveraging Learning Engineering to Orchestrate and Enhance Learning. So I want to talk about why I thought of the term orchestrate. I thought of it because of Bloom's taxonomy. And I was thinking about the some concepts that have been talked about today in terms of scaffolding or encouraging collaboration. And I wanted to be mindful of how what we need to be mindful about is remembering that learners build from the bottom. They need to have anchors. They need to build up to being able to create. And when we're building these learning environments, we have to think about how to scaffold all levels of this. Like, don't throw the baby out with the bathwater. Helping the learner to remember and understand and apply and engage in these processes to build the knowledge that they need in order to work in collaborative groups and create and evaluate information. I in particular have focused a lot more on these two levels in terms of helping students to learn how to understand information and how to apply that information in various situations. So I'm going to talk about that, grounding some of this in my own work. I focused a lot on reading and writing and literacy, and in particular on developing literacy technologies. I'm going to talk in particular about two of the technologies. One is iStart. So iStart is a tutoring technology that provides adaptive instruction and training for reading comprehension. And it's focused primarily on self-explanation and comprehension strategies. For example, helping students learn how to paraphrase and monitor their comprehension. And most importantly, learn how to make bridging inferences and make connections among the ideas in text in the context of explaining the text. And they also learn how to summarize and ask questions. And this is done via natural language processing in which we build feedback mechanisms so that they are receiving feedback, but also in the context of a game-based system. So they play games that allows them to learn the strategies, and then it allows them to implement them with automated feedback on the quality of their summaries, questions, or self-explanations. Another tutoring system that we've built is called the Writing Pal, and it provides strategy instruction on writing. So, for example, you can break up strategy instruction and give people strategies on how to prepare to write, how to write the introduction and body and conclusion, and it also, and how to revise. And it also is game-based. So there are 9 instructional modules that include videos and games. And it also includes writing practice. So the students write essays and they receive automated feedback that by algorithms that are driven by natural language processing. So some aspects of iStart and Writing Pal in relation to learning engineering. One of the things that is kind of a core of the concept of learning engineering is that it addresses problems. And that is at the heart of iStart and Writing Pal. So why did we develop iStart? Well, the reason is because many students cannot understand challenging, low cohesion texts that are required in their content courses. Why did we develop Writing Pal? Because many students have not been provided with basic writing instruction and opportunities to practice writing with feedback. So another aspect of learning engineering is taking into consideration the needs of your stakeholders. So thinking about your users and using user-centered design in essence. So both of these systems provide adaptive tutoring. And so we've worked on the interfaces and on the systems to make sure that they're enjoyable, but also that they're effective. We also have a teacher interface for both of these systems. So the teacher interface is serving the needs of the stakeholder who has to work with the student. So it allows choosing lessons and modules and games and viewing students' performance at various levels. And then at the other level, we built these because we saw an opportunity for researchers to use these to be able to manipulate various aspects of learning experiences related to reading comprehension and learning reading comprehension strategies, as well as writing. And so there's an experimenter interface that allows researchers to investigate and control various parameters, like what the prompts are, the games, whether there are games or not games, or the types of games and the types of modules and what is being provided to the students. So I'll say that they work. We've got lots of papers showing that they enhance self-explanation, they enhance performance on writing, they improve comprehension, they improve knowledge of writing. They result in a better, more positive attitudes towards reading and writing, and the games work as well. They don't improve instruction because that resides in the pedagogy and in how we're approaching what they're teaching, but they help to improve engagement, enjoyment, and persistence. So moving on, I wanted to talk about writing, and I start in writing panel in terms of multiple facets of development. Getting back to this idea of the collaborative work and what goes into building a system like this. What can you look forward to when you're building a system like this, and what kinds of research endeavors are people engaging in? So obviously the ultimate goal is enhanced learning and performance. But beyond, in fact, and we should show those effects. But beyond that, what are we looking at when we're building a system like this? Well, I see 5 aspects of development that lead to various collaborations and research output. One is the interface. The second is the pedagogy itself. The third is engagement. Fourth is feedback. And the fifth is feasibility. So in terms of the interface, what you're looking at when you're building a system like this is basic human factors and usability. So you need to, we do a lot of user research. We do a lot of work just to make sure that what we're building is usable. Sometimes this is basic human factors, and sometimes it's a lot of user-centered work. Another is multimedia design. Now, sometimes we have money for that, and sometimes we don't. But when we do, we try to build engaging and pleasing interfaces that use a variety of resources to help us put that together. And that involves various people who are involved in the design. Another aspect to think about is your operating system. Some of these systems we've been developing for about 20 years. So we've gone through many operating systems, and they love to close them down. So then you have to start over, which is kind of like getting kicked out of your office, and then you have to clean everything up and start over. So it can be a good thing. So going from Java 6 to Java 5 to HTML5, it all kind of helps to make everything move forward, but you have to look forward to that. And that goes along with the programming language, and choosing that and thinking very carefully about what you're building and what kinds of programming languages and operating systems you need to function in. So pedagogy is, of course, extremely important. We're talking about learning, and we're talking about teaching. And so we think about what are the key ingredients to the whatever system we're building. We always build a theory of change. So what do we think these key ingredients are that are going to lead to the change that is expected? And this involves both the content that goes in as well as the process and mechanics that you expect to be effective. So in our case, I tend to focus on strategies rather than content, in the sense that I've always been focused on teaching students strategies that they can carry with them to help them to learn and to be able to perform better in other situations. So strategies on how to comprehend very difficult text, and strategies on how to write basic strategies so that they can carry that forward. I've also always focused on active generative learning. I come from cognitive science, where my initial work was in the generation effect. And so that stayed with me in terms of the kinds of things we build always involves some kind of generative activity, some kind of active learning process. They're all interactive, and they're all adaptive, because that is kind of the core of an intelligent tutoring system, to adapt to the learner and build in these student models that allow you to adapt to the training to the students. The other aspect that we focus on is engagement. So building tutoring systems that are engaging and appealing, and in particular game-based. So we learned early on that games are effective for engaging students. They're also effective for your learning engineers, that it is more fun to build games than it is to build quizzes. And so it's something that is, it's interesting to look at the different kinds of games. It largely boils down to agency. But game-based systems help to increase variety and also help to increase engagement in the learning process. Feedback is critical. It's an often ignored aspect of when you're building algorithms. So once you have an algorithm that predicts performance, that's almost or virtually useless without knowing what the pedagogy is and how you're going to give feedback. And so our feedback algorithms are critical to this. We've done a lot of work on that. They're mainly in our world powered through natural language processing, so features of the language that the students are using. Then finally, feasibility. Feasibility is important in thinking about the teacher interface, and basically always thinking about what the teacher needs, not what you want to build. What do they need, and building something that they need and they can use, and working with teachers while you're building these systems. And in terms of those, we're predicting student performance and providing feedback that teachers can use. And this is actually a pretty hard process in creating a feedback system that teachers understand and can use, and fits their particular needs. So one of the things that we're, part of this workshop is thinking about machine learning and AI and augmented intelligence. And this happens across the board in these two systems. So we're looking at interactivity and adaptivity. We use user logs, we use natural language processing. And as I said, what we're trying to do is predict student performance and provide feedback that teachers can use. One of the things that is the backbone of the work that we're doing is natural language processing. And this started a long time ago by building Cometrics. Cometrics is a system that people still use to give basic indices related to the difficulty of text. And we've also built many other systems that are available online and for free that can give aspects of text on various levels. So the one way to think about this is in terms of looking at the linguistic properties of text. And so, for example, when we think about the readability and quality of text, of course, Rob's paper is excellent, but we can think about it on various levels, like the lexical sophistication. So how hard are the words, or how easily comprehensible are the words in a particular text? The syntactic complexity of the text, the cohesion, do the sentences flow from one to the other, or is there good flow from paragraph to paragraph? And then the semantics, does everything go together? Is it relating to other things, and to how do the words relate to each other? We've used these kinds of models to create models and predictive algorithms of various things. So combining machine learning and natural language processing, you can predict a large number of things, like self-explanation quality, I've already talked about, essay quality. We've also built models on collaboration. So looking at the language that people are using and building models to predict the degree to which people are collaborating. We also focus on creating component scores so that you can understand the variance in various aspects of what people are producing. So, for example, component scores on text difficulty and writing scores. And then what I call reverse engineering, so creating models of the student. For example, you can take what somebody has written and predict their vocabulary, their reading skills, their working memory capacity, creativity, and authorship and course performance. So there's a lot of power in language. And when you have these resources to look at what the students are saying, we can tell a lot about them, about their needs, and also their assets. So just to almost close, I'm not actually sure how much time I have, because I don't know what time I started. But I wanted to say that we've seen a lot of advancements in the last 3 decades in educational technologies in general. So there's a lot of work across the board in terms of orchestrating learning actions. So using various technologies to orchestrate learning across multiple levels, the students and teachers, as well as using artificial agents. We have used educational technologies to augment human capacity by supporting teachers and parents. So I think that there's a lot of work to be done in terms of building systems that augment their ability to perform more quickly, as well as something that we're working on, which is working toward more stealth assessment, particularly on stealth assessment of literacy skills in our world. And then, of course, in revealing learning. So building models, automatic and stealth assessment, and AI and machine learning, building models and how we can predict learning and reveal the learning processes. And so just a shameless plug, I'd like to plug Technology, Mind, and Behavior, our new journal, and 2 papers that are in there more recently, one by Ryan Baker on learning engineering, and then another by Katie McCarthy on toward more effective and equitable learning. So these are 2 papers that summarize a lot of the things that I've said today, along with that toolkit book that I've pointed to, which is really good. So I don't know if I have time for this, but what lies ahead then is basically, AKA, what am I currently focused on? Well, I'm focused on this data problem a lot. So when I talked about these student factors and contextual factors, how do we get these large databases? Much of the research in learning sciences is focused on just a few factors, one factor at a time, a little bit blinded, but much of the data on learning from instructional technologies is hard to access at scales, and there are a limited number of factors measured or manipulated in any one study. And one of the problems is the balkanizations of digital learning platforms. Data are compartmentalized within each platform. And you can only get data within ad hoc requests, or you have to create, of course, your own small study. And many researchers are shut out of platform-based research. And so we need large-scale research and development infrastructures that open up data to external researchers and link a wide variety of digital platforms at different educational levels. And we need this because in order to create a complete picture of the student over the long term at multiple levels, we need inclusive research infrastructure and community support. And of course, because this is learning data, one of the biggest concerns is how to do this while securing the privacy of the individual and the institution. One of the things we're working toward at ASU is the Learning at Scale Digital Learning Network platform. And we are creating a platform that will be provide data to researchers and make data, student data, accessible to researchers, both within and outside of ASU, that protects and honors institutional and individual privacy, so that researchers can conduct studies both on historical data and through exploratory and experimental methods. This is in the context of something called CERNet. It's being run by IES. So there are other technologies that are part of this. And one of them is at your university, run by Ben Motz. Well, some of you are at Indiana, not all of you, since this is a virtual talk. And so big shout out to Ben, who couldn't be here today, but he's also working on Terracotta. But there's Mathia through Carnegie Learning Assessments, and also OpenStax. We're working together to think about these problems and how to make data more accessible to researchers across the board. Beyond the data, scale, generalization, and impact, and that's where I think learning engineering can help, and how we can bring people together to think about how to bring people together across these various silos. So we've seen people working in silos, researchers in one silo, educators in another, ed tech companies. We can keep growing these silos and thinking about how people are relatively isolated, and we need to build these bridges between these silos so that we can all work together. My ultimate goal, and I'm focused on learning, how to improve education and how to improve outcomes for students and a diverse and wide range of students. And to say our future depends on collaborative research and implementation. And there you go.
Perfect. Thank you very much. Everybody clap in what way you feel it's comfortable for you. Questions are welcome. And while you're finding your hand, I have a question, and I'm glad that you're talking about the silos at the end. And given that I don't know much about it, it's probably naive, but I was just wondering, could you comment a little bit on how widely are those technologies implemented in the school system? What kind of schools implement them? Who should be the one who helps bridge this gap, maybe between educators, researchers, programmers, and the school system?
Yeah, I mean, that's an excellent question, because it depends on what kind of system you're talking about and who is developing them. So there are a lot of systems that are being used in school systems. Now think about Carnegie Learning. Mathia is used by quite a few students. And there are I'd say many systems being used by schools. One of the big questions, though, is the extent to which they're being driven I'm not talking about Mathia, but some systems that are being used are driven largely by marketing. So if they have a lot of marketing, then they are used. If they are built by researchers, they often don't have marketing, and then they kind of die out. So there are a lot of intelligent tutoring systems, for example, that have been built, but then not scaled out. And one of the questions would be why? Is it marketing? Or another aspect of it is the extent to which we're building things that really fit the needs of the teachers, rather than some one-off thing that we just think is cool. And how to get the right systems to the teachers, into these educational environments, is a big problem. That I think the government and other agencies are working toward. There's a lot of activity in that realm, and how to match. I think one of the biggest problems is matchmaking. How to match the needs of the educators to what we have out there, because we just have a lot of stuff. The second problem that is actually giving educators the support they need to use technologies and to use these materials. Teachers, educators are overburdened, they are overworked, and they are underpaid. And that's not something I can control, but it is something that we need to acknowledge and think about when we're building these kinds of technologies and support systems for teachers, is that we can't build things that take more time. And we often do. But what we're trying to do is cut down things. How do you support teachers? How do you scaffold them in the ways that they are comfortable with? Because they also have to trust what you're building. So building explainable AI, building explainable systems that teachers are able to trust and use.
This is great, thank you. Maybe Dr. Lin, you can comment, maybe in the general discussion, we can talk a little bit more about that. What might be the role of National Science Foundation or other agencies in this kind of transfer of all this knowledge, of this wonderful research to the schools. But now I would like to invite Niki to give his talk, and then we can discuss further. Thank you. And thank you for the wonderful talk, Danielle.
Okay, thank you. Let me share my screen. All right, does that look okay to people? Is that showing up? Okay, great. So thanks for having me here. And Danielle, that was a great talk. I think there are going to be some interesting connections, hopefully. Certainly connected challenges, shared challenges, if nothing else. So just a quick background about me. I'm at Carnegie Mellon right now. I've been there for 15 years or so, but I started my career as actually a designer doing internet stuff. And then I have a PhD in cognitive psychology from UCLA, which is how I got to know Rob in the first place, but have also been doing a bunch of stuff around more social psychology, relevant theory stuff around, Wikipedia and how do large scale communities work. And, I'm in a school of computer science where we use a lot of tools and build a lot of systems that are more around, AI visualization and interfaces. And so the talk today is a little bit maybe different from, a traditional psychology talk, but I'm hoping that, really I found that the interesting things for research for me lie in those intersections between all of those disciplines. And I'm so excited that this group of people that's on this call, getting to know you and getting your perspectives on this. And if there's anything we can do together, I think that'll be amazing. So let me get started with a quick thanks to collaborators, funding agencies, a lot of people involved in this work. And I'm going to start with kind of a quote that I like from Manuel Castells, on why is it that we as a species have been so successful over the last 10,000 years. And he says it's our ability to creatively accumulate and recombine knowledge and information in non-routine ways. And I think the best example, analogy for this that I've had is actually from Matt Might. So I'm kind of stealing and adapting it here. So the idea is, here's a circle that has all of human knowledge in it, okay? And you start off in elementary school, a little bit. You go to high school, a little bit more. You go to college and you get a little specialty. Maybe you get a master's degree, you deepen that specialty. You go to graduate school for a PhD and you start getting to the edge of knowledge. You read papers that take you to the edge of knowledge. And when you get there, you focus, right? And you push at that edge of knowledge for years and years and years. And finally, this edge of knowledge gives way. And, we call this a PhD, right? And, not to knock this, right? I have a PhD. This is how knowledge expands, right? This is absolutely a normal and necessary process. But the challenge, the problem here is, right, the edge of knowledge is not fixed. It's like expanding, constantly expanding. And our brains have not really expanded or evolved, really since we diverged from Neanderthal. And, I've put a picture of the most evolved human I know on the right here to provide a contrast. So this is a big problem, right? The amount of information is exponentially expanding, and our ability to make sense of that is not expanding with it. So what do we do about that? And I think one thing that's really interesting about the internet is that, you know, on the one hand, it has more knowledge than we can possibly consume. So, you know, we are trying to, if you're a patient trying to figure out what to do about a new diagnosis, there's a ton of information out there to help you. You know, if you're an academic, you can now access everything you could possibly read or more. There's more JavaScript frameworks that you can shake a stick at to choose between. If you're a patent examiner, you can access, you know, any prior art. But our ability to process all this information is really limited, right? And very inefficient. So it turns out this is sort of a back of the envelope calculation from a variety of papers that have looked at internet usage. Is we spend something like 1 trillion hours a year. This is all the cognitive effort and work that we're doing, and we're doing it all individually, and we're throwing it away because no one else benefits from it. So can we, because of the internet, because we're interacting with the internet through a mediated technology, through a browser, through you know, the various ways that we collect and store that information, instead of holding it all in our heads, can we externalize that and then now share that with other people? And that's what we've been looking at in our lab, is really this question of how do we externalize the work, the thinking, the mental models that we build, and share them with others, and what kind of benefits can we get from that? Can we kind of turn this, create an exponential of our own, where instead of starting from scratch each time, can we build on the work that each other have been doing? And I think, you know, we've been looking at this in a very broad manner across lots of different environments. I think one connection to what Danielle is doing is, right, like learning now sort of takes place throughout your life, right? And whatever topic you're learning about, whether it's you're planning a trip to Italy, or you're trying to reskill and do a new into a new job, or even if you're trying to learn physics in class, people are using internet resources all the time and trying to build on what other people have done. So can we make that process more efficient and effective in the transfer of these mental models from people who've already done some of the work to others? Now, that's really, you know, it turns out like this is a really hard problem. And we've been looking at this for a while because, you know, I certainly can't claim that we have any answers, but I'm going to talk a little bit about our thrusts in trying to unpack this and build systems that can help. So the first thing I want to do is point out one of the big potential challenges here, which is the diversity of people and their goals and their mental models and what matters for them, right? So let's say that I'm, you know, Danielle is planting, you know, plants in you know, a nice sunny area with lots of sun. I'm over in Pittsburgh, right? And you know, it was just, we get these cold, icy snows. So maybe we wouldn't actually, you know, her planting a garden and my planting a garden, like maybe that just doesn't make sense for us to share that, right? So we first wanted to look and see, the first thing we did here was to try to see how does diversity of goals or just like natural variation in people lead to the usefulness of these kinds of artifacts. If we could, you know, sort of Wizard of Oz, pulling out your mind and, you know, allowing someone else to build on it, how that works. So we did this as a study. We had people create knowledge maps. So basically for a bunch of different topics like this, we started with an extremely lo-fi approach where we would basically give people a bunch of things we found from the internet. We printed them out, we put them on a table, we said, hey, just, you know, go through this. You're starting a vegetable garden, you're planning a trip or party, go through and kind of make a decision about what you're going to do, and you can sort of build this up on your map. And then we would give someone else, you know, so it might look something like this for the first person, then we would give this to the next person, and they would take this and decide what they wanted to do. Keep it, go throw it away, just redo it, add to it. Then we give it to a third person, we give it to a fourth person. And you can see kind of what's happened here is there's been some structure that is built up in this case, and this is a super common thing that happened. There would be a sort of a tabular structure, right? So you've got different things you have to consider or different topics, and people kind of going through that, and that built up over time. So we did this as an experiment where we would give people either one of three maps created from one of three conditions. So this is a separate group of people, either just the first map that someone used later, or basically the map that had been iterated on by three people before. And what we found was that if you or the map that had been iterated on once, so by one person, that's iterate one. So what we found was that, what I'm showing here in terms of quality measures, we had a few different quality measures. This is self-perceived quality in terms of the helpfulness of the map for them. And we also had some other measures that are in the paper, but what we found is that compared to the solo map, so the one that they had one, nobody had iterated on, the map that four people had iterated on was judged as significantly higher in helpfulness to the person who was doing it. So there seems to be some value to the map, even though people are different, and we noticed that people, even planning parties, had different styles and different goals. And I'm going to unpack this result first and then go into the iterate one. So what is it that made these maps better, even if the people were very different? And what was really interesting is that we coded how helpful people found the content of the maps, like the things that they found, versus the organization, the structure of the maps. And people found the organization much more helpful, and the content relatively unhelpful compared to the organization. So this is a representative quote: although I deleted 50% of what was on the other knowledge map, gave me some ideas right away on where to look and which factors or questions I should consider during my search. So to make that more concrete, right? So, even though Danielle and I are planting very different gardens, like both of us need to think about soil acidity and temperature zones, right? And the kinds of, arrangements of plants and combinations that you might want to think about. And that kind of structure is particularly useful and seems to be able to generalize better across people than the specific content of the map. So there is something I didn't tell you about yet, which is what happens when one person is iterated on this map. And interestingly, we found that if you have one person iterate on it, then the maps were actually rated lower in quality, right? So they're sort of like in this transition phase. You haven't kind of abstracted out the most generalizable stuff yet. And so we get this bump. It's sort of like so now if you're thinking about how do I scale this up or get this out, this becomes sort of a challenge. It's a catch-22, right? Like the map that's iterated on a lot is quite helpful, but the one that's iterated on once is kind of worse. So it's like, who's going to get to the fourth iteration, because you're just going to start from scratch every time. And so the question is, like, how do we get over that hump to where people can start really building on each other's work? So to do that, and now I'm going to talk about a system we built to try to address that issue. And this is work done by my student Michael Liu and with Brad Myers at CMU. What we were really thinking about is, how do we create a system where we can make the benefit to the user just for the first person higher than the costs to the user? So even for the first person, it's useful, and we can start to get that knowledge out, and maybe we can start to combine it afterwards in a more aggregated way. So to do that, there are systems that do try to do some of this already. There's implicit systems like social navigation, collaborative filtering, but a lot of these don't really capture, they leave behind a lot of these mental traces and structure that's going on in people's heads. How are they thinking about it, right? Like in those tables that I was showing you that people were creating before. On the other end of the spectrum are these explicit systems. So people using relevance feedback or getting people to create mind maps. And unfortunately, here we've seen a lot of adoption issues just because of the costs. It's really costly to provide feedback for every single thing that you're looking at. So what we need to do is create a system where the costs are lower to the individual, but the results are still useful to people that are coming after them. So we did a study. We started looking in the domain of programming, and programming is really nice for a number of reasons. First of all, because nowadays programming is really, about remembering what to Google and copying and pasting, right? So these are, fictional joke books here, but there are studies showing that, up to 40% or so of the time spent programming is spent looking for information on the web. You can go on Stack Overflow. How do I do this? What do I do, to solve this problem? And so there's an opportunity here. There are a lot of tools that help people to find information on the web and keep track of where that came from. But finding information is really just the first step, right? There's really understanding the trade-offs between all of the different approaches that you might take is where we thought developers were spending a lot of their time. And so we did a study of developers choosing, for example, choosing a JavaScript library would be one of the challenges that we ran into when we talked to, we interviewed about 10 to 15 developers, some professionals, some students, and this is sort of a typical, thing that they were trying to do. I've got 100 different JavaScript libraries. Is React better? Is Angular faster? Which one has a larger community? There's so many different pieces of information I have to pull together from different places. So how can we help developers organize this information about trade-offs? Not just find it, but take it and organize it. And would that be helpful for subsequent developers in understanding why you made that decision? And a developer would call this design rationale. That's important because a lot of times developers are picking up the code and building on it of what other developers are doing. So what we found in our study is, first of all, people were indeed frequently swamped by decision-making, balancing costs, for example, between cost and performance when picking a crypto algorithm. And about half of them had tried to use tools to go beyond their own heads in doing this, but there were a lot of issues that we found, copying, pasting being too much work. It's difficult to synthesize these things. It's difficult to compare them. It's difficult to keep track of where they came from. So we developed, and then the third finding is that developers were creating these sort of mental tables to compare these different options. React, Angular, Vue, is it fast? Is the development community high, larger or small? And what we found is that this kind of table, comparison table thing for trade-offs was quite common. And in fact, when we looked at Stack Overflow, most of the answers that we found could be organized into a table about trade-offs. And about half of the general questions, some of them were just like, how do I solve this specific thing? And so it seemed like there's an opportunity here for creating some kind of comparison table type of structure. So in this case, we're looking at options. What are the different things you could choose? What are the different criteria you can evaluate on? And can we help people collect the evidence and whether it's sort of positive or negative, and the trade-off, so they can more clearly look at the trade-offs. So I'm gonna, we developed a system called Unikite. It's basically a Chrome extension. I'm gonna show you a really quick demo of this. And so here it's, you can see Unikite is a little sidebar here. I'm just gonna pause it. This is a sidebar in your browser. What's happening on the left here is that the user is collecting a bunch of pieces of information. You can just like hold down Option and drag to collect a piece of information. And they're showing up here on the right. Right now, they're just individual snippets of information. Okay, and then the user is now dragging those into the table, and they can now drag evidence in, and you kind of put it on the left if you think it's positive, put it on the right if it's negative. And what happens is you can basically very quickly build up a comparison table that captures all of the evidence into a sort of organized form, and we hope faster than you would do normally. So to test that, we recruited 20 participants where they did 2 tasks. Either used Unikite or like a Google Docs to do 2 tasks that we asked them to do, and then a real programming task that they're doing themselves. And we asked them to use Unikite since they're sort of familiar with their other process that they would do normally. We found about, so here we just measured overhead cost. So the percentage of time spent on directly using the features in the tool, and we can measure that by looking at the videos of what they did and counting that amount of time, because you do still have to collect things in Unikite and then drag and drop them where they go. And we found that there's a significant improvement in terms of overhead costs, and people obviously like these tables much better. They capture everything and where it came from and the original context as well. So what we were really interested in is, well, all right, great, we can get out what's in people's heads a little bit better. Can we also help the second person in understanding what the first person did? So we did a study where we gave people either tables from Unikite that were created by a previous participant. So here it's how to represent matrices in Python, and there's a number of different approaches like using ND arrays or NumPy or lists. And or we gave them the same set of web resources, so they didn't have to Google and such. They used the same set of web resources that we gave the original person. So we wanted to see, it's a bit conservative, but we wanted to see what kind of speed up can we get? Can they use and interpret what was happening from this table? And first of all the participants answered all of the questions correctly. So that was not a dependent measure. What we were interested in is how fast they could do it. And what we saw was, an over double speed up. So about 2 minutes to answer the questions versus, more than 5 minutes in the control condition where they had all of the same web resources, and they were trying to explain why a particular code decision was made. So it seems like there is at least some benefit. Maybe there's a opportunity here for helping developers capture and organize, really helping anyone capture and organize evidence in a very lightweight way. If we can capture more about the structures people are building, maybe that can be useful for people later. And we've done a number of studies since then that I'm happy to talk about, where, okay, can people interpret those? Can they decide whether it's good or bad? Should I evaluate whether I should trust this information? How do I use it? And there's really, this is just kind of one small piece of how we externalize people's models. I think there's a huge opportunity on what to do there. So where do we go from here? This is really what we're trying to do. I'm going to end with this. I think similar a little bit to what Danielle was saying. I think we need a platform to be able to really explore and test and evaluate these, almost like a particle accelerator, but for the web, where people can, every time information goes around, it collides, it combines, we can start to almost click together this knowledge and test it. But how do we test it? We need some platform where we can get people to voluntarily use this for all of the different kinds of mental models and tasks and activities that they're doing in their lives, that researchers can test things on, introduce new interfaces, analyze data. We can train better AI algorithms, right? There needs to be some kind of way to kickstart this process of knowledge acceleration. So that's what we've been working on. We have a platform that we've started to build called Schema. And, again, we're really at the beginnings here of that. And what we're trying to do, I want to give you the vision of what are sort of the entry angles and the kinds of things that we could help people with, where they would voluntarily want to use these systems, but we can externalize their minds and help share them with each other. So the first that we've started with is this idea of tab management. So, right, like how many of you have too many tabs? Probably, almost all of us, right? And we have a paper from a couple years or last year now showing, what, it's not your fault. It is actually, tabs are really used for 7 different purposes, and they're bad at all of those purposes. And how do we help people with better interfaces to declutter your mind? So that's where we started, and I'll talk more about that in a second. Once we are there, so the solution there is sort of like helping people create different projects or spaces that can capture all of the different things going on in their lives and switch between them. Can we help people to actually go through and make better evidence-based decisions? And I showed you a little bit from the table structure and what to do there. And we have a bunch of work looking at that. And then, people are now using mobile devices more than ever before, but these devices are incredibly poor. They're so much worse at doing the kinds of sense making and decision making that we want to be able to do, but maybe they could be even better, right? What if they could be better than using your desktop? So we have a number of explorations around how that might be possible with new ways of capturing information, organizing it, and comparing things using touchscreen devices. And then finally, ending with this idea that we throw away 1 trillion hours of thinking. Can we start to aggregate and accelerate knowledge and learning? So this is my pitch. If you're interested, we have a system called Schema. It is a platform. I use it today. I'm happy to show you in the discussion how I use it. If you're interested, it's in closed beta, but here's a link that you can go straight to the Chrome store page and download and join without going through the invite line. Feel free to send an email invite too, or send me an email if you want access to it. I would love to hear kind of how you think about it and what ideas you might have for it as a platform that might be useful for you in studying this. We have about, well, now it's over 500 users. Many of them have been using them for almost a year. They use it like 30 times a day. We have someone who put 6,000 tabs in it. So, we're starting to see, we have a pretty good 30-day retention. That's like 10x the market average. So we're starting to see, I think we have something that's kind of interesting as a starting platform for studying sense making and augmented intelligence. Where we're at on this is, again, like we've started with this, that it's really, really hard to do this kind of work. So we're looking for kind of models of how we can continue to fund this, how, we're sort of bridging academia and commercialization, right? Are there ways to make it sustainable? So if anybody has seen models that work really well, we'd be really interested in hearing about that and learning from that. So finally, I've put a few as goodies. These are AI generated things about knowledge acceleration. You can say in the comments what you think best represents knowledge acceleration and the talk if you'd like. But feel free to reach out to me. I would love to hear from you, and looking forward to continuing the conversation. Thanks, everyone.
Thank you very much for the wonderful talk. Great. If there are any specific questions for Niki, please raise your hand. I will start with maybe a little bit sad question. Sorry, this is wonderful technology for improving the wisdom of the intelligence of the crowd. Are you aware of any attempts to use such technologies for bad purposes, let's say, to guide the crowd to a wrong direction? And what could be done? Should something be implemented in the technologies to try to prevent that, or is that an inevitable consequence? Or can you just talk a little bit about it?
Yeah, that's a great question. Something we think a lot about. I think I also teach a class on the social web, so I think there's about 1,000 examples there that we can pick from that are kind of using technology for ill, right? Like all of the misinformation and cascades, information cascades you see happening on social media are great examples of this. I think the internet itself has evolved to be, I don't know if you feel this, but it's sort of in some sense an information sparser place, even though there's more of it. There's if you look at search engines and the way that people optimize for that, a lot of really kind of poor quality results now come to the top for a lot of different situations. So I think the way that we set up incentives and the way that attention is being commoditized is sort of naturally led to a lot of negative things. And so I guess the way that I think about how we could attack this is really, can we sort of change the incentives or the tipping point in some sense? Can we make it harder to propagate false information than it is to propagate true information? In our systems, if we have evidence and you can trace every single thing back to the original evidence, right? Could we do things like, have juries of people spot checking that to check and see if there are people trying to insert falsehoods or biases. I think there's correction mechanisms we've learned from places like Wikipedia that we could maybe apply to things like this. And so I absolutely think that's a huge challenge, but my hope would be, and I think maybe there are people on this call who've been looking at sort of evidence based decision making and things like that, how do we create a better way that changes those incentives?
Yeah, thank you. Which I think brings me also to a general question, which I will keep until Jeffrey asks it. So Jeffrey, do you have a question specifically about Niki's talk? Or?
Jeff, you're muted, by the way.
So I'm fascinated by this, and I just downloaded the beta to play around with. And I guess my question is two parts. Is, if you do have time in this question and answer to show us you playing around with the beta, I would find that really interesting to see. And specifically, I guess my question has to do with also with your talk about trade-offs. Is there is a lot of things that when I'm searching, there's a lot of things that do kind of cluster or are related to trade-offs, but every once in a while there's something that I would call kind of singular, right? It's like it's outside of my categories. I don't know where to put it. And that's often more or less the interesting thing. And sometimes I'll even, like, if I have two screens, I'll put that on the other screen so it sits there for a couple of days. And I'm just wondering if that, is that part and parcel of what we're doing when we're browsing for information, and how do you build tools that allow you to have the singular things as well as the kind of clustering things?
Yeah, that's really interesting. So before I go down the wrong avenue, can you give me an example of like a singular thing?
So I don't know, the first time I saw Midjourney, as an example, was like a singular thing because I didn't really know what it was. Now it's a cluster to me because I've used all these different tools. But the first time I saw that was like singular, and that was something I wanted to think a little bit out as a phenomenon, because it was not only like DALL-E, but it was also remixing.
Yeah. So, okay, that's great. So I think there's two quick answers to that. The first is that's super common, right? A lot of our tasks, I would say the long tail of the things we're interested in, we have like one or two examples of, and as we keep going, maybe we come across more examples and we say that's interesting, and for a lot of those, they just kind of leave, right? So I think we need to think about how do we create a system that allows for that long tail, right? Like all of the systems you have today, tabs, tab groups, tab managers, all of these things try to create spaces that all compete equally for your attention. But what you really want are things that you can put your attention away, but can like come back and resurface to them. And what we found in our interviews was that one of the reasons that people weren't closing their tabs was because they had all these singular things lined up that they wanted to get back to someday. And we said, when are you going to get back to that? And they said, honestly, like, I'm not going to get back to this, but like, if I put it away, it goes in a black hole, and I'm like giving up on my future self and that opportunity. And we said, oh my God, that's really interesting, right? So I can show you in Schema, but we have the beginnings of that where you can, there's a few different ways where we kind of manage your attention. You can put things away, but then they get resurfaced later. So that's the start, at least.
Thank you.
Thank you. Yeah, I completely understand those who don't want their future self. Marina, you have a question.
Yes, thank you so much for a wonderful talk. I also downloaded the schema for my browser and will check it out. But I guess I'm intrigued by the first results you presented on the map organization project. I was wondering if, like, the second person and after 4 iterations, do you think the people early in knowledge organization and later in the iterations were doing different were performing different cognitive operations, doing something qualitatively different to the information? Or do you think they were doing something similar, but it just pays off after several iterations? So basically I was wondering if you have any data on that.
I'm not sure we have data on that specifically. That's a really interesting question. I would love to sort of explore that more. I guess my intuition, though, would be that they are not doing very different things. Like they seem to be, trying to plan their party and evaluate the venues and figure out what should I care about. What they were finding were, it was really more easy for them to understand the structure of what they should be considering. So like, oh, I didn't think that I need to think about music, but I should check what the music is for the venues. Or they would find things that were not obvious from the data, like someone had said, oh, you know what, this is on the other side of the bridge from the location, but like it's really hard to cross that bridge, right? So I think we haven't really characterized all of the different ways in which the cognitive processes are similar or different. And in sense making, you do see like a very big difference when you're in the foraging phase and you're just trying to understand what the space looks like versus trying to synthesize and make decisions in that space. So is it that we're accelerating people more quickly into that phase, or are they and there are some people who actually looked at every single piece of evidence, because again, even the ones that were thrown away by other people because they sort of didn't trust and didn't understand like if the other people's goals or knowledge matched their own. So I think there's a lot to unpack there. It's a great question.
Thank you. And now I would like to open to a more general discussion for both of you, Danielle and Niki. And my first question, my first reflect also what Jim was writing in the discussion, and that's what do you think about kind of introducing more interactions between your two lines of research? So Danielle is doing excellent research on augmenting, in my understanding, kind of individual intelligence is using these technological advances, using augmenting you through technology. And you, Niki, are mostly working on social augmentation, augmenting individual intelligences through social interactions. What are some possibilities for applying more of, for example, crowdsourcing, collective intelligence work in the educational technologies? And Niki, so this question for you, Danielle, and Niki, could you learn from this extensive work on how individuals' cognition work, how they learn, what biases and problems they encounter to perhaps further improve the crowdsourcing technologies? Thank you. If you would like to start, whoever wants to start first.
I'm happy to start. I guess, yeah, I'm super interested in, I think what's happening, the way I think about this is like we are basically trying to unload people's mind and reload what is needed for them, whether it comes from someone else's mind or maybe their own later. And, that is really, to me, just core to the question of learning. And I think there's interesting things there about, right, like, what do you need to spend your time learning, right? Like we know from like desirable difficulties, levels of processing, we know all these things that like, you can't just acquire something in your head wholesale. You need to learn the pieces that make it up and, go on. But at the same time, you don't know every single thing about how your car works and you can still drive it, right? So what is that trade? Like, to me, that's a really interesting trade-off that I would love to learn more about from the educational side, is like, how do we support scaffolding the core concepts people need? How do we think about aggregating across people? And that, I'm guessing there are many differences in learners that could be modeled that might be relevant for us as well. So, a novice photographer versus an expert photographer is going to use different information in different ways and might not be relevant to each other. Or maybe you want to accelerate people along that path by giving them. So I think there's a lot of interesting things that I would love to learn about.
So I think about this in multiple ways. One is in educational research and in educational technologies, quite a few people are working on the technologies to scaffold. Let's take for example, a teacher, rather than giving them a tool that grades an essay, giving them a tool that scaffolds the process of grading the essay. So giving them information that facilitates that process, which is, quite a bit like what Niki is talking in terms of scaffolding. You're reducing the amount of information that you have to deal with and process, and taking some things off your plate that can be done automatically. So there's quite a few systems like that. Another realm that you can bring this in is how to, there's work on, let's just, peer grading. So how to bring students together with a teacher, systems that have been built on facilitating that collaborative process of peer grading and peer feedback for assignment. So that too is kind of like a system that allows this collaborative process on understanding what others are doing and also judging what others are doing.
Mm-hmm.
Overall, I think that this relates to not only scaffolding somebody in terms of their individual work. So what, at the heart of this is, what is your problem? And then how many people have this same problem? I don't have a tab problem, because I open so many tabs, I just close them. I do a garage sale every day, like every hour, all the tabs go. Well, bye-bye tabs. I promise I'll find you again someday, but you're going bye-bye. And another strategy I have is, if I'm in a meeting and you know how in the chat, like a million things are like, read this, read this, read this, read this. So I just open an email and I've got the chat, I write a note, I never look back at it. But if I ever do, I've got all the papers on this topic that I could possibly need, that I'll forward to somebody else and they can read them. But the whole notion of how to build these systems that will help us build better systems, I love that. I mean, I could see, so many applications on how to bring people together. So one of the things is the systems themselves, building systems that solve people's problems, that help scaffold your world in technology or outside of technology. It's, it's basic human factors problems. And then the other is how to build systems that help the people who are building the systems, and how to organize that information so that we can make more rapid, agile changes and understand what the data is telling us. And so that's one of the things I love about what Niki is doing, is thinking about that process and how to facilitate people collaborating together to build things.
Great, thank you. Exactly what I was hoping for. The enthusiasm for each other's work. Yeah, and definitely combining technological and social scaffolding seems to be the way to go. And it's interesting to hear how you think about it. And my other question is, and perhaps Dr. Lim, if you wish, you can also jump in. You do amazing stuff, both of you. So there are a lot of great applications. And we started a little bit to talk about it. So what are some barriers that you see in spreading the word about these good technologies in the broader public, the public for which they are designed? What are your opinions? Whose role should it be to basically promote these tools that are partially built by taxpayers' money, to the taxpayers that actually could most use it? Your audiences are different. It's more obvious for you, Danielle, that you really the students would profit from this, and certainly there is some obligation probably of the government or a funding agency to do something about it. Maybe a little bit less obvious for you, Niki, but also if you want to develop an educated citizen that can cope with all the challenges and the fast pace of life and all the new information you need to process, it is also extremely important. So can you all kind of reflect on this? What would be the ideal scenario? What kind of support of agencies could you use? Or do you think that it should be left more to kind of commercial interest and to select those that seem, those applications that seem most promising and so on? Thank you. Whoever wants to start.
Well, I have to be honest, I didn't hear everything you were saying, but that's okay. I'll take a guess on what the question is, or maybe I'll just relate it to some problems that I see in terms of scale and taking technology to scale. It is a big problem, and one has to do with expertise and interest. So let's take the quintessential academic scientist who in their garage builds this fantastic tool that maybe solves a problem for a few people, but it works really well. It has great algorithms, and but that quintessential scientist wants to keep doing science and has no interest in going out into the business world, because they became the quintessential scientists because they hate business people, and they hate selling things, so they want it to be free, and then they want to do the next scientific question. They don't want to go out, and their university pays them enough, and so they don't need to. So what happens is that technology does one of three things. One, it could die. It just goes and stays in the garage, and nothing is ever done with it other than a publication. Two, it could be bought by the quintessential company that really just wants to bury it so that it doesn't overshadow their quintessential lovely product that works, but maybe not as well. Three, it could be, I mean, a lot of people provide these things for free, and then they also, one of the things I'd like to point out is that even if you have developed something like that, a lot of the times it is inspiring the companies. Some people think about it stealing your work, but it's inspiring companies to build things that are similar, and those ideas are taken forward in other products. Now, ideally, there are people who do take this on. I do think that there does need to be the whole notion of a university that has ways of scaling up and supporting faculty in commercializing their tools and the things that they're building is a little off-centered in terms of thinking about who those faculty are and what they want to do with their lives. They don't want to sell off their ideas, but at the same time, they don't want to sell their life and become that person. And so we absolutely need to find that middle ground of universities, philanthropic organizations, finding a way to work with people so that we can build scalable technologies, scalable solutions that can be marketed in different ways. Because one of the things I found is a lot of people don't buy something if it's free. So like all of my technologies are free. Go to adaptiveliteracy.com. You will find iStart and Writing Pal. I suggest you not do that this week because we're moving to the cloud and we've got a new programmer coming on. So maybe just put off that for a couple of weeks. But we've worked very hard to provide our technologies for free. Now, how long will that last? It will last as long as it lasts, and then we'll charge for it. But one of the things that I really think about, though, is the extent to which not only do these technologies, are they something in and of themselves, but they also change the world in other ways. They inspire people to do other things, and I focus on building up tools for researchers so that they can build other things. Niki is building tools for researchers so they can build other things so that we can facilitate that process. So it's not all in building one thing and then commercializing it. It's how do we work together to improve the life of others.
Yeah, I think that's a wonderful and I agree 100%. And I face, I got into this in part because I got tired of making these one-off systems that were really cool in the lab or with a small group, and then the student leaves, and then there's no being able to build on or allow other people to build on things. So we got a little bit of funding to be able to create this platform, but it really feels like I've just learned over the last few years the enormous amount of work that goes into not just building a usable, really, excellent platform that beats what else is out there, but distribution. This is the first thing that a startup will tell you about, is like the biggest problem is really distribution. It's not how good your product is.
Right.
And distribution is something we're terrible at as as faculty, and we don't really have access to the expertise to kind of do the kinds of things you need to do. So we're doing them now, but I'll tell you, it's been a painful, long, a lot of effort that has nothing to do with my day job. We're getting ready for a product hunt launch. We need to engage with influencers. You need to figure out how your viral coefficient can get above 1, right? Like, these are all these things that we're not very good at. So I think there needs to be, I'm 100% with Danielle, like, what is there that allows us to create these types of platforms and research that doesn't require, every step of the way, it would be so easy for me to just say, oh yeah, let's just go commercialize this. Let's go kind of throw it over. But then you sort of lose control and the values that got you into this in the first place. So how do you navigate that balance? I don't know. Here are a couple of random ideas that probably won't work, but number one, what if we could have a internet stack that was by the government for every person, right? Like, how hard would it be to create a new browser, to create a new search engine, to create a social network that we could use as platforms for experimentation, and try to have an incentive structure where things are implemented that are measurably for kind of societal good, right? Like, how much would that cost? I don't know, but it doesn't seem totally implausible. Number two, is there some kind of accelerator that would help with the kinds of expertise that people need? So, obviously we can't have, I actually think there's something good in letting ideas go out into the world and having many of them die because they, maybe it's not the right time, maybe it's not what was needed. But a lot of times we can't tell whether it was a good idea or not, just because we never had the expertise to be able to test that. So, could it be, maybe there's some kind of organization that could train students to be real product managers, to be to be help with the distribution side of these things, right? We have dozens of students who are happy to get involved with our faculty projects. Is there a way to help, train them better to help with the things that, they're not just doing some little one-off independent study, but could actually gain some expertise in building product and platforms and the research involved. So anyways, I think it's a great question. I think some kind of funding, the third would just be some kind of funding that would actually support the testing of these hypotheses without requiring it to be commercialized, and keeping that in the research realm where you can innovate and throw more, continue with the innovation that's happening in the research side. And I think in some sense that might be the easiest short-term solution.
Thank you for these thoughts. Dr. Lin, did you want to jump in with any thoughts from your side on like barriers and current thinking about these issues?
I think it's very useful to hear some of these concerns and comments and ideas for potential solutions. There's not enough time to get into this. I'm conscious we're over time, but perhaps we could put together for the September, Rob, if some of these things that have come up, and then we can address that more, little bit with some thought and preparation with regard to some of the resources that you might be able to tap into. So
That's actually a wonderful thought, which brings me to my announcement for the next couple of weeks. So the next week we still have kind of standard seminar series with Paul Maldina and Jerry Zhu. And then on September 15, as you said, we have an open discussion. You're all very welcome. We can continue these discussions like this in a session. So it's sitting together. The speakers, we invite all the speakers so far, and the audience is invited. And we can discuss such questions, and also some of them are that we already put down are combining human and machine strength, collective algorithms, improving performance of human groups, social coordination, computer-assisted learning and education, effective AI for humans, spread of misinformation. So those are just some possible topics. We'll somehow organize it so that we have time to do some of them, and then we can also add this, basically the scalability of the new technologies for augmenting human intelligence. Thank you very much. Did you want to say something?
yeah,
Jolie?
I was going to say I would welcome any, for those of you who want to share some of those thoughts of issues that we can discuss maybe on September 15th, to just go ahead and email me. And then
Great.
this way I can even maybe perhaps get some other program officers or
Perfect.
resources that will be helpful to this group.
That's wonderful. Thank you very much. You can also email us or post on Slack. If easier is the DARPA for augmented intelligence needed, maybe to be discussed. See you all next week, same time, and then on September 15th for the general discussion. Thank you, Niki and Danielle. Thank you, Dr. Lim. Thank you, Marina, for organizing, and see you all. Bye-bye.
Bye, everyone.